Hi everyone, let's do a review for CPM2 Module 3. Let's do the review for the test. At the beginning of your review sheet, it says this is a practice test and not an actual test. We have attempted to give you questions that could be on the test. It is a sample of the questions from the homework. However, all the questions on the test come directly from the homework. So if you want to see what the questions are on the test, rework all your homework. Yeah. Show all your work on this paper in a neat and orderly manner. You can attach a sheet of clean notebook paper if you want with your work on it. That's fine. Use a pencil so that you can erase any mistakes and circle your final answer. That is most helpful when we're grading. If we can't figure out what your answer is, it'll be marked wrong. When you complete the test, look over the test carefully and see if you can find any errors that you need to correct. Good luck. You know, when I'm working a test, one of my test-taking strategies is if I get an answer but I'm uncertain about it, I put a star by it, you know, just in case time might be running out. Then when I'm done with the questions I know I can work, I come back to the ones with the star and spend some more time with them. Okay? All right, here's an answer bank. My suggestion is you go through the entire review first, work all the problems, and then come back and grade yourself. Check each one of the answers. If you got all the answers, fine, you're done. If not, then you can just fast forward to that part in the video, and you don't have to watch the whole thing. Of course, you don't have to watch it at all if you don't want to. All right? All right, vocabulary and definitions. Fill in the blanks. Choose from the vocabulary listed below each question. Number 1 says, identify the name given to 3y in the following fraction. 3y is right there. 3y is called the what? In that fraction, 3y over 2, 3y is called the numerator. Yeah, 2 is the denominator. Number 2. The smallest positive number divisible by all denominators in a list of fractions is called the, well, it's not equivalent fraction. It's not improper fraction. It's not mixed fraction. It's got to be the least common denominator. Number 3, fractions that represent the same portion of the whole are called, well, they're not mixed. Equivalent, yeah, not improper, not proper. They are equivalent. Fractions that name the same part of a whole are equivalent, just like these are. All of those are names for 1/2. Number 4, the fraction 5/9 and 7/9 are called what? Are they mixed, improper, like, or unlike? Yeah, they're like fractions because their denominators are both 9. While the fraction 5/7 and 1/6 are called what kind of fractions? Yeah, those are unlike because their denominators are different. 5. Choose from the choices below in each question. Okay. Which of the following is a correct statement about a proper fraction? Remember, a proper fraction has a numerator that's smaller than the denominator? Okay, a proper fraction has a numerator which is greater than or equal to the denominator. No. B, a proper fraction has a numerator which is less than the denominator. Yeah. C, a proper fraction has a numerator which contains a variable. I know the choice has to be B. Even though I knew it was B, did you see how I went ahead and read C? Yeah, it's wise to do that. Okay, what are equivalent fractions? And we just talked about that. Equivalent fractions are fractions that represent different portions of the whole. Nope. Equivalent fractions are reciprocals of each other. You know, reciprocal of 2 over 1 is 1 over 2. Nope. Those aren't equivalent fractions. Equivalent fractions are fractions with the same denominator but different numerators. Nope. Equivalent fractions are fractions which represent the same portion of the whole. That's it, because we just got done talking about that. So our answer choice is D. 7. What fraction represents the shaded part of the figure shown here? Well, in a fraction, your denominator shows you how many equal parts the whole was cut into. So this is number of parts in the whole. And this talks about how many of those parts are shaded red. So we've got 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 equal pieces. And then go back and count how many of them are shaded red. We've got 1, 2, 3, 4, 5. So 5 eighths. If I'm going too fast, definitely pause the video. Okay, skill and drill. Number 8, graph the given fraction on the number line. The fraction is 5/6. Here's my number line. Here's 0. It's positive, so we don't need that section of the number line. From 0 to 1, let's see how many equal pieces it's cut into. 1 piece, 2, 3, 4, 5, 6. It is cut into 6 equal pieces. This is 1/6, 2/6, 3/6, 4/6, 5/6, and 1 whole is the same as 6/6. I'm going to put my dot right there. That is 5/6 of the whole. All right, simplify. I've got a negative numerator divided by a positive denominator. What is negative divided by positive? Yeah, that's negative. And 62 over 62, that's 1. Negative 1. All right, simplify. I've got a whole that, I don't even know what this represents. If it was just a whole not cut into any pieces, it would say like that. That represents a whole that's not cut into any pieces. But 24 over 0, I can't even explain what that is. My mind can't even wrap around it. The answer here is undefined. Remember that? Yeah, you can't divide by 0. Number 11a says write the mixed number as an improper fraction. I know most of you know how to do it, but let me draw a picture to remind you what that means. 3 6/7 means I have 3 wholes and 6 pieces of another whole. So this is what we've got as a mixed number. But as an improper fraction, I'm going to take each one of the wholes and divide them up into 7 equal pieces. So there's 7 pieces here, and there's 7 equal pieces here, and there's 7 equal pieces here, which gives us 21 equal pieces plus 6 more pieces here. That's 27 equal pieces, each piece divided into 7 equal pieces. Well, now the shortcut here is take 7, which is the number that each of the whole is being divided into, multiply by 3. You can see here why you're taking 7 and multiplying by 3. That gives you 21. And then add on these 6 pieces here, and you get 27/7. So the fast way to do that? Fast way. Denominator times whole plus the numerator. And then put the answer over your denominator. Okay. 12a. I don't know. It says 11a. I don't know. Is there an 11b? Because I don't see it. Did I not copy it? Okay, I found it. 11b says, write the improper fraction as a mixed number. Well, 35 over 6, that fraction bar is a division symbol, and it says 35 divided by 6. Well, let's see how many times 6 goes into 35. The number on top always goes underneath this division symbol. Okay, 6 times 6 gives us 36, but that's too much, so let's use 5. 5 times 6 is 30. Subtract, and we have a remainder of 5. So we have got a total of 5 wholes and another 5/6 of a whole. That's how you change an improper fraction to a mixed number. You just go ahead and divide. 12a, write the number 54 as the product of prime factors. Okay, I'm going to use a factor tree. And I'm going to take 54. I know it's divisible by 2 because it's an even number. So 2 times what gives you 54? Yep, that's 27. If you need to go ahead and do this, please do so. Okay, 27 is not prime. I know it's divisible by 3. 3 times what gives you 27? Yeah, that's going to be 9. And 9 is not prime because that's 3 times 3. So it looks like my prime factorization is 2 times 3 times 3 times 3. You can write it that way, or you can write it as 2 times 3 to the third power. We'll accept either one of those as your answer. Okay, let's do prime factorization of 64. 12b. 64, I know that's 8 times 8. 8 times 8 is 64. Each 8 is 2 times 4. And each 4 is 2 times 2. So it's 2 times 2 times 2 times 2 times 2 times 2. And another way to say that is 2 to the what power? Yeah, 2 to the 6th power. Number 13, simplify the fraction. I've got 6x over 30. Well, another name for 30 is 6 times 5. 6 times 5 is 30. And now you can see that the 6 in the numerator cancels out with the 6 in the denominator. You can, if you bust this up, you can do this. Because if I were multiplying these back together, I'd multiply straight across and get this. And I would multiply straight across the denominators and get that. 6 over 6 is 1. And 1 times x over 5 is x over 5. (14a), we're multiplying. The first thing I looked was to see if either one of these fractions here will simplify, and they won't. So when you multiply fractions, it's straight across. 5 times 7 is 35. 12 times 12 is 144. I can't think of any number that divides evenly into either one of those. So we're done. 14b. I'm going to show you how to do this 2 ways. Okay, my first method, I'm going to take a positive number times a negative, which gives me a negative answer, and I'm going to multiply straight across, numerator times numerator, denominator times denominator. Well, here's my negative, because positive times negative is negative. 6 times 5 is 30. I need to figure out what 15 times 12 is. I got 180. Now, you always need to simplify your fractions. Ever since you started learning about fractions, I know your teachers told you need to simplify. Always, always, always. The thing I notice about these two numbers, they both end in 0, and that means they're both divisible by 10. Okay? So you just knock off the zeros. Am I done? No, I noticed that 3 divides into 18. So we're going to reduce 1. And our final answer is negative 1/6. Yeah, you always want to keep reducing until you can't reduce anymore. Okay, here's another method. Here's a second method for doing the same problem. I notice right here that 6 and 15, before we even start to multiply, both of those are divisible by 3. So if I divide the top and bottom by 3, I get 2 over 5. So I'm going to take this positive number times this negative number, so I know my answer is negative, and I'm going to multiply straight across. Numerator times numerator, denominator times denominator. And I also notice a 5 in the numerator can cancel out with a 5 in the denominator, leaving me with, leaving me with negative 2 over 12. 2 and 12 are both even. They're both divisible by 2. Divide top and bottom by 2, and you still get negative 1/6 as an answer. Okay, so you pick your method. Which way do you like to do it the best? All right, 15a. We're multiplying, and once again, it's straight across. Numerator times numerator. So 3x times 3, denominator times denominator, 7 times 5. Now 3x times 3 is 3 times x times 3. And it doesn't matter what order you multiply in, you still get the same answer. So I'm going to call it 3 times x, and 3 times 3 is 9. So I get 9x over 35. And 9 and 35 don't have a common factor, so we're done. 9x over 35. Okay, let's do the same thing here. I'm going to take numerator times numerator and denominator times denominator. Okay, and I'm going to put a little multiplication symbol here because 3x means 3 times x. And I can cross simplify before I finish this up. I notice that 5 divides evenly into 5 and 35. 5 divided by 5 is 1. 35 divided by 5 is 7. Do you also notice that 3 and 6 are both divisible by 3? 3 goes into itself once. 3 goes into 6 twice. So it looks like my numerator simplified to 1 times x times 1, which is just x. And the denominator looks like it's 7 times 2, which is 14. So my answer is x over 14. All right, moving on. 16, we're going to divide. How do you take one fraction and divide by another fraction? Yeah, you take your first fraction and you multiply by the reciprocal of the second fraction. So I'm going to flip 7/9 and call it 9/7. So that gives me 27 times 9 over 7 times 7. There's no factors in the numerator that's divisible by any factors in the denominator. So I'm just going to have to take 27 times 9. That's 63. That's 18, 19, 20, 21, 22, 23, 24. 243 over 49. It can't be factored because none of this can be factored down and canceled out. And it's okay if you leave it as a proper fraction. If you want to go ahead and change it to a mixed number, you're going to have to go through this whole process. I wouldn't even bother. Go ahead and leave it as an improper fraction, unless your instructor told you otherwise. Okay? I'm going to move this out of the way so I can get to B. All right, I have a negative divided by a positive. My answer is going to be negative something. All right, I'm going to take the first fraction. How do you divide by the second fraction? Yeah, you flip the second fraction, you take the reciprocal, and you multiply. And when I multiply, I get 6 times 11 in the numerator and 11 times 36 in the denominator. Do you see what I see? Yep, the 11s cancel out. 11 goes into itself once, 11 goes into itself once. So I'm just left with 1 here and 1 here. And I also noticed the 6 and the 36. 6 goes into itself once, and 6 goes into 36 6 times. So when I simplify, the answer is still negative. Don't lose the negative sign. In the numerator, I just have 1 times 1. Denominator is 1 times 6. The answer is negative 1/6. All right? Let's find on 17 1/3 of 27. Let me do it with a model first, and then I'll show you how to do it mathematically. Here I've got 27 dots. Go ahead and count them. I've got 27 dots, and I'm going to divide those into groups of what? I'm going to divide them into groups of 3. One group of 3, second group of 3, third group of 3. I only want 1/3 of that whole, so I only want that many. And if you count it up, that's 9. So I know my answer is going to be 9. 1/3 of 27 is 9. Okay. That word of is a multiplication word. That says 1/3 times 27. You can change 27 and make it a fraction. And now you can multiply straight across. That's 27 over 3. And 27 divided by 3 gives you 9. Taking 1/3 of a number is the same as dividing by 3. Taking 1/2 of a number is the same as dividing by 2. Taking 1/5 of a number is the same as dividing by 5. All right? All right, 18, we are adding. Nice thing here is on 18a we have like fractions because the denominators are the same. I've got 2/13 of a whole, and I'm adding another 5/13 of the whole. Together I have 7/13 of a whole. On B, I'm real happy here also because I still have like fractions. All right, my denominators are the same. So the answer is going to have that same denominator. I have 3 over 17x plus 5 over 17x. 3 of these plus 5 of those gives me 8 over 17x. If you're adding or subtracting, you need common denominators. Once you have your common denominator, you add or subtract your numerators. Okay, on C, we don't have like fractions. So I'm going to have to find a common denominator. I'm going to show you the long way and then tell you what the easy way is. On D, you can tell what your common denominator is. It pops right out. But on a problem like C, it doesn't. So you can take the largest, hold on a minute. I took the largest of the two numbers. I took the 13 and I listed multiples of 13. 13 times 1 is 13. 13 times 2 is 26. 13 times 3 is 39. And I kept going until I found a number that ended in 0, because then I know it'd be divisible by 10. Well, look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It took the 10th multiple of 13 to get me my common denominator. So the easy thing to do here is just go ahead and take 10 times 13. When you do this, you may not have the least common denominator, but at least you'll have a common denominator. You may have to simplify your fraction in the end. So my common denominator, and in this case it happens to be the least common denominator, is 130. So what I'm going to do is change both of my denominators to 130. Okay? Let me move this out of the way. 10 times what gives you 130? Yeah, that's 10 times 13, so I have to multiply the top by 13. Well, I know 13 times 2 is 26. I need to take 13 and multiply it by 10 to get 130. So I need to multiply this by 10. So this is 50. So I have 26 130ths plus 50 130ths. I add my two numerators together and I get 76 over 130. Now I hope you notice that it's not simplified. How do I know it's not simplified? Both of these end in an even number. So I'm going to have to divide both by 2. Unless you can think of a bigger number they're both divisible by. I'm going to divide this by 2. That goes in there 3 times. That's 6. Subtract and I get 1. Bring down to 16. 2 goes into 16 8 times. So if I take this and divide by 2, I get 38. And 130 divided by 2, that's 6. 6 times 2 is 12. Subtract and you get 1. Bring down the 0. 2 goes into 10 5 times. All right. I can't think of anything that divides evenly into those two. I believe I'm done. All right, let's go on to 18D. All right, let me erase all of this. Did you catch all that? Because I'm erasing. You can pause. Okay, on D, I have unlike fractions. They need to be alike. What's my common denominator? Yeah, it's 18. Because 9 times 2 gives you 18. So multiply the numerator by 2 and you get 4. What's 4/18 plus 5 more 18ths? That's 9/18. Am I done? No, I can simplify. Divide top and bottom by 9. 9 divided by 9 is 1. 18 divided by 9 is 2. 1/2. All right. Here we're going to subtract. Between a denominator of 3 and 5, what's my common denominator? Yeah, it's 15. 3 times 5 gives me 15, so I have to multiply the numerator by 5. 2 times 5 is 10. With the 5, I had to multiply by 3, so multiply the numerator by 3, and I get 3. What is 10/15? Subtract 3/15? That's 7/15. You just subtract the numerators. All right, here I've got 2/7 over, subtract 1 over 36. I need a common denominator. I don't know what it is. I'm going to do it the long way, and then I'll tell you what a shorter way is. Okay, I'm going through multiples of 36. 36 times 1 is 36. 36 times 2 is 72. And I know that 72 is not divisible by 7. 108, well, I don't know. I had to check it out. And no, it's not divisible by 7. 36 times 4 is 144. Is 144 evenly divisible by 7? No, it is not. So I keep doing the process until I get a number that divides evenly by both of them. And I didn't get there until I took 36 times 7. I took that denominator times that denominator, and I got 252. So you might as well have just multiplied those two together in the first place. So let me go ahead and change this. My common denominator is 252. 252. I had to multiply 7 times 36, multiplied by 36 to get to 252. So I've got to take 2 times 36. Well, 2 times 36 is 72. With the second fraction, I had to multiply 36 times 7. So I need to multiply the numerator times 7. And that gives me 7. So I've got 72 252nds, subtract 7 252nds, keep your denominator, and subtract your numerators. I got 65 over 252. Let's see, I know they're not divisible by 2. 5. If you add the digits in a number and the answer is divisible by 3, then the number is divisible by 3. Well, 11's not divisible by 3. I think we're pretty much done here. That's our answer. All right. Number 20. All right, I'm going to have to erase all this so I can find number 20 down here. All right. I've got x plus this number equals this number. I want to get x by itself. How do you get rid of addition by this number? You subtract both sides by that number. So, whoops, where did it go? Well, I kind of undid all of my erasing. Let's do that again. I want to get x by itself. I have to get rid of addition by 11 over 32. I'm going to subtract 11 32nds from this side, which means I'm subtracting 11 32nds from this side. That's a zero pair, and I'm left with x equals, what's negative 1 32nd? Subtract 11 32nds. If you need to change the subtraction to adding a negative, do that. How many 32nds do you get? Yeah, that's negative 12 32nds. They both are even. They're both divisible by 2. So let's simplify. We still have negative. 12 divided by 2 is 6. 32 divided by 2 is 1. 6. 16. Okay, there was another number bigger than 2 that they were both divisible by. Yeah, it was 4. Let's go ahead and divide this by 2 and divide this by 2. I get negative 3 over 8. That's okay if we didn't notice that the top and bottom were both divisible by 4. You can simplify in 2 or 3 steps. That's all right. 21. Solve and simplify. Negative 11 times z equals this number here. I want to get z by itself. How do you undo multiplication by negative 11? Yeah, you divide by negative 11. And what you do to one side, you have to do to the other. Well, I've got a fraction divided by this whole number. Let's make that whole number a fraction by putting it over 1. On the left-hand side, I'm just left with z. How do you take this fraction and divide by this fraction? You multiply by the reciprocal of the second fraction. So it's 121 over 5 multiplied by 1 over 11. Now we just multiply straight across. Numerator times numerator. 121 times 1 is 121. Denominator times denominator is 5 times 11. And I left it like this because another name for 121 is 11 times 11. And do you see how an 11 in the numerator cancels out with an 11 in the denominator? Leaving me with 11 over 5. If you want to leave it improper, that's fine. If you want to find out how many wholes are there, 5 goes into 11 twice with how many fifths left over? Yeah, 1/5. Either one of those answers will be acceptable. All right, number 22. Z times 11/5 equals 121 over 5. How do you get rid of multiplication by z? Multiplication by 11/5? You can divide both sides by 11/5. And what you do to one side, you've got to do to the other. This is one strategy. These cancel each other out, leaving z equals 121 over 5. I'm going to change this to multiplying by the reciprocal. All right, that's a 5, not a 6. This gives me 121 is 11 times 5 over 5 times 11. These cancel each other out. 11 goes into itself once, 11 goes into that 11 once, and I'm left with what? In the numerator, I've got 11 over 1. My answer is 11. All right, another way to have worked this problem was to multiply. If you just want to get rid of a fractional coefficient, multiply both sides by the reciprocal of the coefficient. This will be 55 over 55 when you multiply across. 55 over 55 is 1, and 1 times z is z. And do you notice how this is the same as this? Yeah, it just allows us to skip one step. So whichever way you want to do it, we're still going to get 11 for our answer. 23, graph the inequality and express in interval notation. Okay, well first I have to solve the inequality. I want to get x by itself. I have to get rid of addition by 5. So I'm going to subtract 5, and what you do to one side, you've got to do to the other. I'm left with x is less than or equal to what? What's 2 subtract 5? Yeah, that's negative 3. So let's find negative 3, which is right here on the number line. Since it's less than or equal to, I have to have the bracket. If it just said x is less than 3, then at negative 3, at negative 3 I would have put a parenthesis. So the parenthesis shows you don't include the negative 3. But here, it can be equal to 3. All x values less than or equal to 3, your arrow goes that direction. So now we've graphed it. And in interval notation, this continues to go on to negative infinity. And since you never get there, we'll put a parenthesis. Negative infinity, you always put your smallest number followed by the largest number. When you're doing interval notation, it's your smallest, comma, your largest. So our smallest number in this interval is negative infinity, comma, the largest is negative 3, and it includes negative 3, so it's going to be a bracket. So there's your answer in interval notation. All right? Application problems. 24. In American Sign Language, in an American Sign Language class of 26 students, 21 are hearing impaired. What fraction of the students are hearing impaired? My whole is 26, and the part I'm talking about is 21. And I looked to see if I can reduce, and I don't think I can. I'm done. 25. Find the perimeter of the following figures, simplify, and write as a mixed number. Perimeter is the distance around. You just add up the length of all the sides. I have 8/15 plus 14/15 plus 11/15. I've got to add those all up. So my answer is how many 15ths? Well, the 14 plus the 11 is 25. I'm going to have to add on another 8. That gives me 33/15. And they said simplify and write as a mixed number. Well, top and bottom are both divisible by 3. That gives me 11 over 5. And then to change to a mixed number, this says 11 divided by 5. 11 divided by 5. 5 goes into 11 twice. That's 10. Subtract and you get 1. So 2 1/5. It's a word problem, so you have to have units. And my units are centimeters. So there's your answer as a mixed number. There's your answer as an improper fraction. Number 26. Find the area and the perimeter of the figure. Okay, area is length times width. If this is my length and this is my width, then I'm taking 4/5 multiplied by 3/5. Multiplying straight across, I get 12 over 25. You cannot reduce that. What's my units? I took centimeters and multiplied by centimeters. So that's centimeters squared. Area always has square units. On perimeter, that's the distance all the way around. So it's 4/5. This side's another 4/5. If this is 3/5, this is 3/5. So it's 3/5 plus 3/5 plus 4/5 plus 4/5. This right here gives me 6/5 plus this right here is 8/5, which winds up being 14/5. Now change it back to a mixed number. That's 14 divided by 5. 5 goes into 14 twice. That's 10. When you subtract, you get a remainder of 4. So that's 2 and 4/5. And the units, that's centimeters, that's centimeters, that's centimeters, that's centimeters. It's centimeters. Okay? One last thing, just a quick reminder. If you have a whole, it's divided into 5 pieces, and you're not considering any of those pieces, what's your answer? Yeah, 0 divided by 5 is 0. 0 divided by any number is 0. But what if I take 7 and divide by 0? You cannot divide by 0, and your answer is undefined. All right, just a little reminder on that. Looks like we're done. So guys, good luck on tomorrow's test. It is the most difficult test of the 4 modules. So definitely spend the time, go back and double check your work, and let's all continue getting those awesome grades. Good luck.